So I'm just going to spend a few minutes talking about the tour PAS has been with our industry partners over the past 20 plus years of business, and that journey we've been on with you, helping solve the problems our customers face. It all started in 1993, and PAS was a systems integration firm. We focused on programming distributed control systems, integrating them with safety systems, and during that time developed deep domain expertise on process safety, on process control, and that deep domain expertise has found its way through our products since we've been building our products since that time. Some familiar faces from the start of the company. Eddie, you still got that suit? That's nice. That is nice. Dennis Aarons hasn't aged a day. Sorry, Nick, you aged a little bit, so he was very young when he joined. So that's how we started. Very early on as a company, we realized that programming and maintaining these new digital control systems was really hard. They were unintuitive, they were complex and interdependent. One manufacturer of one thing, another manufacturer of another, all had to be programmed together. Very limited documentation. You could spend hours and hours documenting the control strategy you just put in, and 5 minutes later it's out of date, just because things change. And just became very difficult to manage in the long term. In order to solve that, we introduced our first software product called Doc 3000 to automatically document the configuration of a control system. No more paper-based documentation. Take a backup of the system and bring it into an environment where you could understand the complete configuration. We also provided intuitive visualization, no longer looking through DOS-like code to figure out how it works, but control maps and visualization, understand how this thing is, which ultimately led to improved system reliability by allowing engineers to make better decisions how to understand, maintain, and make changes on control systems. As time went on, the product became ubiquitous with many different control systems, many different interfaces, to where we can interface with practically anything that you might have in your processing environment to help you understand and manage the configuration of those devices. Our next solution kind of derived in 1998 when we realized that these complex systems we're putting in, these controls, are getting a lot of value, but we kind of forgot about someone, the console operator, the person who has to interact with these systems. We didn't design these systems very well, keeping that person in mind. They had very limited situation awareness. We had just keyhole views of the process, and many of the operators thought they had actually gone backwards. They were used to an analog panel where they could see the whole process, and they were uncomfortable going to digital, which was all basically numbers-based. Alarm floods. Man, alarms were easy and fast, so turn them all on. The result, lots and lots of alarms, confusing the operator, and alarm systems that were worthless during times when they needed it most, during plant upset conditions. HMIs that didn't do a very good job portraying process health. A bunch of numbers up there that are changing, and they had to try and figure out what was going on, and no real clear status to help them understand it. Ultimately, we set the operators up for failure. We weren't giving them the systems they needed to really understand the process, respond to abnormal situations, and keep the process running safely. We relied upon heroics and basically very experienced people. As a result, working with industry, we developed our alarm management and HPHMI solutions, or high-performance graphics solutions, to vastly enhance situation awareness of the operator, vastly improve that, if you will, information cockpit for them to understand the process conditions, take action, and keep the plant running safely. Brought the alarms in control, so we aren't flooded with alarms during process upsets, but the right alarm at the right time. Intuitive displays that provided context of the process, status of the process, so that they could be much more proactive in dealing with process conditions rather than reactive to alarms, and ultimately helped improve plant reliability by ensuring operator success, giving them the tools and information they need to do their job. Our next solution came out in 2004. And the situation at that time is automation had continued to explode. The value of automation is undeniable. We put in more sensors, more valves, more automated processes, but at the same time, we're taking people out of the plants. A processor or a refinery that may have had 400 or 500 people might have a couple hundred people or different numbers, but the point is we could operate these facilities with less. One of the big problems, though, is that the engineers responsible for maintaining all this stuff had a hard time knowing what to work on. We had thousands of loops out there at a refinery or a large petrochemical complex, and only a few people to maintain them. And they didn't know which was operating well, which was not operating well. They had to wait for a big problem before they even knew there was a problem. So ultimately, we became very reactive, and studies have shown just hundreds of loops running in suboptimal conditions for years. Well, in order to solve that, within our technology platform, we introduced Control Wizard that provides predictive analytic on loop performance. Evaluates all of your loops in real time, non-invasively, understand which loops are doing well, which ones are doing poorly, and if they're doing poorly, why they're doing poorly, so we can take action on them before they start causing process conditions or process upsets, essentially providing predictive maintenance on our control loops, which are responsible for so much safety, reliability, as well as profitability of our production facilities. In 2010, we were working with a client. We're helping them solve their alarm problem. That client is actually here today. And they came to us and said, you know, you're really helping us solve this alarm problem, but I've got a bigger problem. Alarms are just a subset of a broader set of operational limits that I have to manage. And I have limits associated with my safety systems and trip points that shut my process down. I have safe operating limits I'd like to be able to maintain. I have my mechanical limits, like my safety relief valve settings, maximum allowable working pressure. And the problem is, these systems are all maintained, or these limits are maintained in different systems. My DCS owns the alarms, my safety system owns the trip points. I got 50 spreadsheets where I keep my safety relief valve settings. And the problem is they're related to each other. There's a hierarchy to them. And having them in different databases makes it very difficult to understand, are they set properly? It's very easy for someone to go in and change an alarm setting and perhaps set the alarm in a place where it's above the trip point of the safety system, which means I'm going to get an alarm after the trip takes place, which does me no good. That leads to the configuration errors, and also very limited insight into the performance of operational limits. Am I regularly exceeding various operational limits? Am I doing well to stay within those operating limits? Well, in order to address that, we introduced our product, Inbound, to provide one place to manage all of your operating limits in one place. It takes that information from the resident system. At the end of the day, it doesn't matter what happens in a spreadsheet. What matters is what's in the real system. The alarms and the DCS should be set properly relative to the safety system, should be set properly relative to environmental limits, and bringing that in from all of those different systems, manage them in one place so we can understand and set our limits well, know our limits. The second thing is providing visualization to those responsible for staying within them, giving operators visualization too. This is my safe operating limit. I just got an alarm. When's the safety system going to trip? Being able to see that all in real time very quickly without having to look it up. Very important for the operator to be able to stay within them. And finally, analytics to provide management with scorecards and reports on being able to know, yes, we're managing our limits, we're staying within them, and I have the evidence to prove that we did. And those are the components that make up good boundary management. Beginning in 2011, a little before, but really from a product standpoint, we recognized in the industry started to really focus on industrial control system cybersecurity, a journey that continues to this day. If you think about it, control systems were not designed with security in mind at all. And we have control systems that are out there that are 40 years old everywhere. Security was never a consideration. Reliability was the consideration. Run no matter what, do your job that you were designed to do and do nothing else. That was what control systems were designed to do. And for several years, we were able to rely upon some pretty basic security controls. An air gap. Well, I isolated the darn thing, no one can get to it, so I'm good to go. Or security by obscurity. Look, control systems are weird and different. Hackers don't know what those things are. They don't care about those things, so we don't have to worry about it. Well, unfortunately, both those security controls have proven to be woefully insufficient. The reality is the air gap has been jumped many, many times. That's well documented. And unfortunately, control systems have become targets, and people have successfully infiltrated and changed control systems. Gary will talk about Triton Trisis a little bit later this morning. So, unfortunately, it is something that we have to address. It's a new risk that we have to manage to our processes, and it's a new discipline we need to instill in our operating facilities around improving the security of our control systems. What PAS did is we took a very mature technology for managing the configuration of a control system, understood those systems inside and out, down to the gain setting on every flow controller, to the program that's running your boiler, all that information, and pivoted that to provide foundational ICS cybersecurity controls. Starting with inventory. What have I got? All the manufacturers, all the control strategies, everything I got in one database. Providing vulnerability analysis, taking information in from other third-party sources like the National Vulnerability Database or ICS CERT or even from the vendors to match the inventory with known vulnerabilities and help you understand the vulnerabilities that are within your environment. And ultimately, providing a very key security, which is managing the configuration of the device, making sure that the changes take place are only the ones you meant to take place, what you designed to take place, and ensure that unauthorized changes are dealt with and investigated and turned back to where they need to be. Spend a few minutes talking about independent protection layers and the dangers of not having a good handle on safety system status. So let's look at the layers of protection we put in place to protect our processes and to ensure safe, reliable operations. It all starts with the automation system, your control loops, and your optimal boundaries. This is why you buy automation. Keep the process where it is. It's like autopilot on the plane. If there's a minor disturbance, the control system should be able to deal with it and bring the process back to optimal operations. The next layer is my people, my operators. Well, there's plenty of times when a plant or a facility cannot operate itself. During startup, you don't push a button and walk away. It's a very interactive time. Those people rely upon alarms, rely upon HMI to understand the process and bring it back to where the control system can again run the process. Our next layer is our safety systems or safety integrated systems or shutdown logic, where maybe things have gone too far. I'm in danger of causing major equipment damage or worse, some kind of environmental or safety incident. And so I engineer a system to recognize dangerous conditions and shut the process down to a safe location to avoid a major incident. If a safety system kicks in, at a minimum, I'm going to suffer economic loss. I need them, but I sure hope they never have to operate or at least minimize it. Beyond that, I have my physical constraints, safety relief valves, other physical constraints, secondary containment to prevent further proliferation of an event. And beyond that, I have emergency response if something takes place. How am I going to respond to it? Each one of these layers are independent. They are designed so that if one isn't there, the other can take care of it. If you look at incident investigation when incidents take place, it's never just one thing that causes an accident. It's usually a series of unlikely events that allows some kind of bad thing to pass through the various layers of protection that leads to a negative consequence. And basically, an accident happens when one or more of these systems fail. And so essentially the holes line up, an incident passes through, and we have an incident. One of the problems when we developed the solution working with a plant manager is I have to manage all of these different layers. There's thousands of protection layers at an operating facility, from alarms, safety shutdowns, all these different things. And sometimes you have to work on them. Sometimes you have to bypass them. Sometimes you have to do maintenance on them. And the real issue is am I managing this properly? Have I, rearranged the cheese slices, if you will, to make sure that I can bypass one thing, but I better make sure another thing is enabled to avoid this particular incident. And so what we did is, leveraging the technology that we had from IPL Assurance, is provide holistic status on all of my IPLs at an operating facility. From the status of my safety systems, have they been properly tested? Are they past due? Are they currently bypassed? How does that affect my current process hazard analysis? Where does that put me from an operational risk perspective? Better manage all these independent protection layers so that I can understand where we are, reduce the chance of an accident, and make sure these holes don't line up and cause an accident. So that, in summary, is what PAS has been doing over the past 25 years, working with customers, understanding what their problems are, leveraging our expertise, and providing solutions to help improve safety and reliability as well as security. So what's next? What's coming next? Well, clearly, as Eddie talked about, we're going to hear a lot about this today and in the conversations. The IIoT, Internet of Things, Industry 4.0, different languages for it, it's here to stay. Its benefits are undeniable. Getting this data out, analyzing it, getting better insight into our production processes, the value is unmistakable. And we're going to continue to see proliferation of sensors and analytics to help improve plant safety and reliability. But this digital plant does introduce new risks. These risks include complexity, more stuff talking to each other, getting more data out, but you know what? We're not going to go out and rip out all those 30-year-old control systems. A lot of those are still going to stay for a while, but we're trying to get more and more data out. Data integrity. If you look at how data has to get from, if you will, the shop floor from a sensor up into some kind of business system, it's got a long way to go through a lot of different hops. How can I ensure I have good data up in my business systems? As I increase connectivity, I increase connectivity on the way back, increasing my cyber threat and my cyber concerns by allowing increased access into these systems. These are risks we have to manage in order to get the benefit we're going to see from the industrial Internet of Things, and it's our job to manage that and reduce that risk as much as possible. So what we are doing, and our next iteration from a company standpoint, and I'm going to give you a sneak peek on this, and I encourage you to go down to the technology showcase to see more there. But basically, we are leveraging the technology we have built upon from alarm management, safety systems, cyber, everything, into one consolidated view of process risk. And I'll explain what you're looking at here as far as one dashboard to look at all of it. On the upper left is one normalized view of two different main sources of risk: cyber risk and operational risk. And beginning on the bottom, the cyber risk can compose, so what is cyber risk? What are things that increase my concern that I have a lot of risk as it relates to security of my control system? Well, things like vulnerabilities. How many vulnerabilities do I have identified on my various devices? What are the status of my patches? How late am I in doing my patches? Do I have any, can't see the one down there. The view is so small, that one. Access into my system, compliance with various standards, all of these things normalized up into one score. On the vertical axis, things for operational risk, things that cause me concern. Have I had demands on my safety system? Have there been issues with controllability from my loops? Do I have an alarm system that is going crazy? All of these things increase risk that something could go wrong. The bubbles you see are basically different operating facilities, and in this case, I'm looking at my refining organization, and each bubble represents a refinery. On the far right, I can see I have one refinery with a high level of cyber risk, the Hecate refinery. And if I want to understand what that is, I click on that particular plant, and now it's going to drill down into the dashboard for that particular facility. And again, now instead of looking at a plant, I'm looking at the different units that are in that plant. So I have the sulfur recovery unit, I have the crude unit, and on the far right, I have my fluid cat cracking unit. And by the way, other information like production performance and trends of risk over time and everything else. But over my FCCU, clearly something is going on. I have a concern there. And by clicking on that vulnerabilities, that section of the vulnerabilities, I can get down into the actual network diagram for that particular unit and see the actual computer where I have a high amount of vulnerabilities as coming from the National Vulnerability Database. Sorry. Trent, go back one way. Thank you. And I can see all of the vulnerabilities on that device, and that is the particular device that is causing us concern I should take action on because the score for that particular device is bad. Okay? So that's the journey that we've been on. That's what we've been doing, and those are where we are going as a company. Eddie talked about convergence. That's basically what we're doing, taking all of this technology we've developed, combining it to provide a holistic view on risk into your process, whether it be operational safety or cybersecurity, so you can make good decisions on where to invest to reduce risk to ensure your facilities run safely.